Welcome back, everybody, to another deep dive. And today we're going to be looking at some really fascinating figures from the history of mathematics.
Oh, yeah.
Pythagoras, Thales of Miletus, and Henri Poincaré.
That's a great lineup.
I know, right? We've got a stack of books and articles about these guys. And honestly, it's just incredible how much these thinkers shaped our understanding of the universe, really.
It's really amazing to consider the lasting impact, across centuries, really, from like basic geometry to the movements of planets. I mean, wow.
Yeah.
Yeah.
So, okay, let's start with Pythagoras. I think most people remember, at least vaguely, the Pythagorean theorem from school, right?
Yeah.
O squared plus B squared equals C squared.
Right.
But there's actually some debate about whether he actually discovered it.
Yeah, that's right. I mean, there's evidence that the Babylonians might have been using it hundreds of years before Pythagoras.
Huh.
Yeah, it's really hard to pinpoint exactly where some of these mathematical concepts originated.
Makes sense, I guess. I mean,
Yeah.
math has been around for a long time, right?
For sure. But what Pythagoras and his followers did, which is really significant, was they systematically studied and proved the relationship between the sides of a right triangle.
Okay.
They took it from a kind of rule of thumb to this fundamental mathematical principle.
So they, formalized it.
Yeah, exactly. And it really highlights this key aspect of math, right? Moving beyond just knowing something works to actually understanding why.
Okay, that's pretty cool.
Yeah, and it gets even more interesting. Pythagoras, he wasn't just a mathematician. He was deeply into philosophy, particularly transmigration of souls.
Whoa, hold on. Transmigration of souls, like reincarnation.
Yeah, exactly.
How does that connect to math?
Well, imagine believing that souls are reborn into different bodies. So you have this concept of eternal recurrence, right?
Okay.
And this might have led Pythagoras to view numbers not just as abstract symbols, but as representations of this deeper eternal order in the universe.
Oh, I never thought about it like that.
Yeah, it's pretty mind-blowing.
Okay, so for Pythagoras, math wasn't just about solving problems. It was a way to glimpse the eternal truth of the universe.
Exactly, and that's a perspective that we see pop up again and again throughout the history of mathematics, even today.
That's wild. So we've got Pythagoras searching for eternal truths in numbers. Now let's fast forward a bit to Thales of Miletus. He's considered by many to be the first philosopher, which is a pretty big deal.
Oh yeah, for sure.
But he was also a brilliant mathematician and astronomer.
A true polymath.
Totally. So he's known for this thing called the Theorem of Thales, but honestly, I'm a bit fuzzy on what that is.
Okay, so imagine you're in ancient Egypt, right? And you're staring up at the Great Pyramid of Giza.
Okay, I'm there.
Now, how would you figure out how tall it is without actually climbing it?
Good question. I guess I don't know, Google it.
Haha, right. No Google back then.
True.
But they did have shadows. Thales realized that the length of an object's shadow is proportional to its height. So, by comparing the pyramid's shadow to the shadow of something he could measure, like a stick, he could calculate the pyramid's height.
That's pretty clever.
Right. And that simple observation led to the Theorem of Thales, which is all about proportional segments when you've got two parallel lines intersected by a couple of other lines.
So it's not just about shadows then?
No, it has applications in all sorts of areas: geometry, trigonometry, even architecture.
Wow. Okay. So Thales was using math to figure out secrets about the physical world. It's like he was paving the way for, the scientific method.
Absolutely. He emphasized observation and reasoning as ways to understand the world, which, are fundamental to both science and philosophy.
Right. I'm sensing a theme here. It's like these early mathematicians were as much philosophers as they were scientists, trying to figure out not just how things worked, but why.
That's a great observation. And now let's jump way ahead to the 19th century and meet Henri Poincaré, who really shook things up a bit. He actually questioned this long-held belief that our solar system is perfectly stable and predictable.
Whoa, okay. Questioning the stability of the solar system? That's pretty bold. What led him to that?
Well, he got really fascinated by what's called the three-body problem.
Three-body problem.
Yeah, it sounds simple enough. You've got the sun, Jupiter, and then some small object, like an asteroid. And the question is, how do they all interact gravitationally?
I can imagine that gets pretty complicated.
Yeah, it turns out to be way more complex than it seems. Poincaré realized that even the smallest change in an object's initial position or velocity could lead to drastically different outcomes over time.
So, like, even a tiny nudge could make a huge difference in where that asteroid ends up.
Exactly. And that's the essence of chaos theory, the idea that even small variations can have huge, unpredictable consequences.
That's pretty mind-blowing. So Poincaré is saying that even in a system governed by predictable laws, like gravity, there's this element of randomness that makes the future uncertain.
Precisely. And that was revolutionary because it really challenged this idea of a deterministic universe, which had been dominant for centuries.
Wow. We've gone from eternal truths in numbers to the inherent unpredictability of the universe. I can't wait to see where we go next with this.
It really is amazing how, across all these different periods of time, you have these brilliant minds trying to grapple with these like fundamental questions.
Yeah, I mean, we've seen how these mathematicians weren't just like crunching numbers. They were asking these big philosophical questions about how the universe works.
Oh, absolutely. Their work was definitely infused with philosophical ideas, even if they weren't philosophers in the traditional sense.
Right, right. So like Thales, for example. There's that famous quote attributed to him, "The most difficult thing in life is to know yourself."
Yeah, that's a good one.
That sounds pretty deep for a mathematician.
Right. I mean, it really reveals this, awareness of the human condition. Like, to understand the universe, you have to understand yourself, your place in it.
Yeah, that makes sense. Like, we can't really see the big picture if we don't understand our own, like, limitations and biases and stuff.
Exactly. And if we think about Poincaré, he was really interested in the philosophy of science. And, especially given his work on chaos theory, he questioned whether science could ever provide us with absolute truths.
So, like, even with all the amazing scientific advancements we've made, we can't fully predict the future.
That's what Poincaré seemed to be suggesting. Like, our understanding of the universe is always going to be limited by how complex and interconnected everything is. Even those tiny variations can lead to unpredictable outcomes, especially over long periods of time.
It's kind of humbling, right? But also exciting. It means there's always more to learn, always new things to discover.
Totally. And I think that ties back to what you were saying earlier about those early mathematicians being as much philosophers as scientists. Their work constantly blurred those lines between disciplines.
Yeah, for sure. It's like they were all using different tools to try to understand these, like, fundamental truths about existence.
Exactly.
Pythagoras saw this numerical harmony at the heart of everything.
Right.
Thales used observation and reason to uncover these, like, hidden patterns in the natural world.
Yeah.
And Poincaré was exploring those limits of what we can know, showing that, like, uncertainty is built into the very fabric of reality.
That's such a great way to put it. And they were all tackling these questions using the tools and language of their time.
Yeah.
It makes you wonder how these same questions are being explored today, right? And, what kind of new perspectives are waiting to be discovered.
For sure. Okay, so we've talked about their mathematical and philosophical contributions, but, like, what's the big takeaway for our listeners? Why should they care about these guys who lived so long ago?
I think their stories show the power of curiosity, right?
Yeah.
And the importance of challenging assumptions. These mathematicians weren't afraid to ask those big questions, even if the answers weren't always clear or easy.
Totally. And I think they also show us that knowledge isn't this, like, compartmentalized thing. Math, science, philosophy, they're not separate. They're all intertwined, part of this shared human desire to understand the universe.
Exactly. And that's such an important message for anyone, whether you're, a scientist or a philosopher or a student or just someone who's curious about the world.
Speaking of learning new things, you mentioned before that Poincaré came up with this really challenging mathematical problem that took over a century to solve.
Yeah.
The Poincaré conjecture, right? What was so special about that problem? What made it so tough to crack?
Well, the Poincaré conjecture is a really fascinating example of how a seemingly simple question can lead to this incredible amount of complexity. It basically asks, if you have any three-dimensional shape that's closed and doesn't have any holes, can you transform it into a sphere without tearing it or cutting it?
That sounds, well, pretty straightforward at first.
Right. But it took mathematicians over 100 years to actually prove it. There's a lot more to it than meets the eye. To really understand it, you have to delve into this field called topology.
Topology. I feel like I've heard of that, but I can't quite remember what it is.
So topology is all about the properties of shapes that stay the same, even when you, stretch or bend them.
Okay.
So imagine a rubber sheet. You can twist it, pull it, but you can't tear it or poke holes in it. Topology is about those fundamental properties that don't change, even when you deform the shape.
So it's not about, like, the specific measurements of a shape, but more about its overall structure.
Right, exactly. And the Poincaré conjecture was saying if a shape is like topologically equivalent to a sphere, meaning you could morph it into a sphere without any drastic cuts or tears, then it must actually be a sphere in disguise.
Okay, I think I'm starting to get it. But why was it so difficult to prove?
Well, because it required mathematicians to come up with these totally new ways of thinking about shapes and spaces. They had to create new tools, new concepts, new language, really, just to be able to work on the problem. It took decades of work by mathematicians all over the world to finally crack it.
Wow, so it's like a huge collaborative effort.
Yeah, like a massive puzzle that everyone was working on together.
That's pretty amazing. It shows how, like, even in math, it often takes this collective effort, like a team of brilliant minds working together to make these big breakthroughs.
Absolutely. And the story of the Poincaré conjecture is a testament to that, you know, to human collaboration and this drive to solve these really challenging problems.
So we've gone from ancient Greece to the 19th century, and I have to say I'm really impressed by the brilliance of these mathematicians and, their commitment to pushing the boundaries of knowledge.
Yeah, me too. And I think what's really inspiring is their courage to question assumptions and really dive into the unknown.
Definitely. And before we wrap up this deep dive, I want to leave our listeners with one last question to think about. What do these three figures from such different times and places tell us about the connections between math, science, and philosophy? Are they really separate fields, or are they all just different ways of trying to understand the same fundamental truths about the universe? It's something to ponder as you continue your own explorations and see where your curiosity leads you. It really is fascinating how these three figures, even though they lived in such different times, all contributed to this, like, big human quest for knowledge. And we talked about how their work blurred the lines between math and science and philosophy. But I want to go back to something you mentioned earlier about Poincaré's work on chaos theory and how it challenged the deterministic view of the universe. Can you explain that a bit more?
Yeah, so for a really long time, many scientists believed that the universe basically worked like a perfect machine, like a clock.
Right.
And they thought if you knew the starting conditions of a system, you could, in theory, calculate its future perfectly.
Okay, so like if you knew the exact position and speed of all the planets, you could predict their movements forever.
Exactly. That was the dominant view, especially after Isaac Newton and his laws of motion and gravity, But then Poincaré's work with the three-body problem, that really threw a wrench in things.
Yeah, because even those tiny variations in the initial conditions could lead to completely different results.
Right. What Poincaré found was that even in systems that seem to follow predictable laws, like gravity, there's this inherent sensitivity to the starting conditions. So, even a minuscule change in an asteroid's trajectory could drastically alter its path over time.
So it's like that butterfly effect thing. Like a butterfly flaps its wings in Brazil, and it causes a hurricane in Florida.
Yeah, exactly. That's a great way to think about it. Poincaré's work helped to establish chaos theory, which is all about recognizing this inherent unpredictability in complex systems, and that's a big shift.
It is. It's like we went from thinking of the universe as this predictable clockwork to something much more, dynamic and mysterious.
Exactly. It's more awe-inspiring, I think.
For sure. So even with all our scientific knowledge, we can't perfectly predict the future.
Yeah.
There's always going to be some element of, chance or the unknown.
Right. And that's one of the really powerful takeaways from these mathematicians. They remind us that the search for knowledge never really ends, There are always more questions to ask, more things to figure out, and different ways of seeing things.
It's like they're saying, hey, don't be afraid to explore the unknown, even if it's a bit scary. You never know what you might discover.
Exactly. And I think that message resonates with everyone, whether you're into math or science or just someone who loves learning new things.
Absolutely. Well, I feel incredibly inspired after this deep dive. We've explored the lives of these amazing people who really pushed the boundaries of math and made us think differently about the universe and our place in it.
Yeah, it's been a great journey, and I hope our listeners are leaving with a sense of wonder and a deeper appreciation for what math can do.
I hope so, too. A huge thanks to you for sharing your expertise with us. And to all our listeners, thank you for joining us on the Deep Dive. Until next time, keep exploring, keep asking questions, and keep diving deeper.